Hi, in this video we're going to be looking at the 2025 KZN Trial Paper 2, and our focus is on geometry, question 8, specifically 8.1. So we read the first question and it says, in the figure below, O is the center. So I'm going to mark that. It's a very crucial point for us to know that O is the center. So if O is the center, we know we can use angle at the center. We can look for radii and lots of other stuff that pertains to the center of the circle. Question goes on to say that P, Q, R, S are points on the circumference of the circle such that QR is equal to RS. QR, which is marked for us, and that is now an isosceles triangle, which means that S2 would be equal to Q1. Okay. Also, another thing to note, which we don't necessarily need to put in, if O is the center, remember that OQ and OS are equal. And therefore, we'll have S1 equal to Q2, another isosceles triangle. Okay, and then it tells us that O1 is equal to 2x, which is marked for us in the diagram. And my first question that I'm going to focus on, it says express the following terms of x giving reasons. They want us to find angle QRS. So in trying to find angle QRS, there's a relationship between QRS and angle O1, and that is our angle at the center. So for my first thing I'm going to do is find O1, and O1 would be 360 minus 2x. And the reason for that is, we're going to write that down. That angle O1 is 360 minus 2x. And that is because angles around a point. It's a revolution. So if O1 is equal to 360 minus 2x, we now see a relationship between O1 and this whole of QRS. So in other words, QRS should be equal to half of 360 minus 2x is 180 minus x. And our reason there would be angle at the center, which is equal to 2 times angle at the circumference. And there we have our first question answered, 8.11. Okay, our next question, 8.12, wants us to find Q1. And I think we spoke about this earlier, that we have an isosceles triangle. So we know that Q1 is equal to S2. And the reason for that is angles opposite equal sides. So we now look at the triangle, the green triangle that I've just drawn in for you. We're going to use some angles of the triangle because we know that the angle R is 180 minus x. So angle Q1 is actually equal to, we're going to take 180 degrees, subtract the angle of 180 minus x, and we're going to divide that by 2. And remember, we need a reason for that, and our reason here, okay, I'm fighting for space, and our reason here for this would be sum angles of a triangle. And if we work this out algebraically, Q1, 180 minus, your negative sign is going to change your sign. So the 180 minus 180 will cancel off. Negative and a negative x will give you x over 2, which we can express as half x. And there we have angle Q1 for 8.12. Okay, we go to our last question, 8.13, which wants us to find angle P. I'm going to put a dot there on that angle P. So remember that angle P, if we look at it, is equal to S2. And if you cannot see it, I'm going to quickly show you why. And we have angles in the same segment. Okay, and then we have angle P is equal to S2. But remember in the previous question, we found that Q1 was equal to half x, and therefore S2 was also equal because they are equal. Remember in the previous question, we showed that angle S2 was equal to angle Q1, which was equal to now half x, proved above. And therefore, we can now state that angle P is actually equal to, remember this is half x, will be half x, and your reason is angles in the same segment. We can have also used, and I'm going to show you the other way, that we can use the fact that equal chords, I'm going to highlight that for you just to show you, that equal chords subtends equal angles. So we have a chord, two chords that are equal, and then they would subtend equal angles. So that can also be used. That angle P is equal to half x, and the reason they would be subtended by equal chords.